So I deliberately helped my rival, and I think of her as my partner, because our job is to make this more exciting for everybody in the state. I also helped my counterparts at 2 other institutions in the state. I'm hoping at least one of those 3 proposals, they're all essentially the same kind of proposal, I'm hoping at least one of them does get funded. Then, of course, I mentioned we're providing these resources. And it turns out the more you help the other institutions, the more you're helping yourself. And then the other thing I mentioned earlier, gigantic return on investment, right? 7 to 1. 7 to 1 is an exaggeration, or whatever the opposite of exaggeration is. It's an understatement, right? The return on investment is greater than 7 to 1, and the fraction of research at the university that we have enabled is better than 1/7. Okay, next slide. Okay, one more piece of information. So I'm kind of wrapping up now. Next slide. So we talked about Moore's law. Computing speed doubles about every 18 months. Yeah, and I showed the picture. Next slide. So there's that picture. And notice, by the way, that supercomputing is getting faster and faster. Faster than computing is getting faster and faster. That's because we're getting better at parallelism, at doing more things at the same time. Next slide. So here's the rule. If it's a supercomputer today, guaranteed, it'll be on your desk or your lap in 10 to 15 years. And by the way, it'll be your phone in 25. So how many of you have a cell phone? Okay, hold it in your hand. That's the fastest supercomputer in the world 25 years ago. In fact, it's probably faster than the fastest supercomputer in the world 25 years ago. So if you learn about supercomputing today as a student, what you've actually done is you've learned about the future of computing. You've got a 10-year jump ahead on the competition. Now, I realize in North Dakota you have a very strong economy with a very low unemployment rate. Much of the U.S., that's not true. It's very competitive out there, very hard to get a good job. And so having a competitive edge is very important. Okay? By knowing something about the future, you are more competitive today. Knowing the future is very, very hard to do. Next slide. So here are those numbers, right? So roughly to one significant figure, an undergrad is 20 years old. Roughly to one significant figure, life expectancy in the U.S. is about 80. So how much time do they have left? Doing it in your head. 60 years. By the way, they don't understand that it goes by like that, right? They think they've got forever. So how much faster are computers going to be 60 years from now? Well, 40 times 1.5 is 60. So we're going to have 40 doublings between today and the day they die, right? Roughly. Okay, well, so 2 to the 10th is about 1,000, which means 2 to the 20th is about 1,000,000, which means 2 to the 30th is about 1 billion, which means 2 to the 40th is about 1 trillion. So the computer they've got today on their lap and the computer they're going to have the day they die, well, the day before. The day they die, it's not that useful. But the computer they're going to have on their lap the day before they die is going to be 1 trillion times faster than the one they have on their lap today. We can't possibly imagine what we're going to be able to do with 1 trillion times more computing power. But we know it's going to be amazing. We can't see that 60 years into the future, right? And this rule about 10 to 15 years from the supercomputer to your laptop, that's not going to get us the 60 years. Think of the 60 years as the far horizon. We can't get to that far horizon today. But what we can do is we can get up on our tippy toes and we can look over the fence into the neighbor's yard to see a little bit of the future. Because the problem with the future is the future comes too fast and in the wrong order. And I think that's my last slide. Next one. I think it just says questions. Yes. So I'll take questions. Both here and out in TV land.
Henry, this is Bonnie Nias from
Hi,
NBSU.
Bonnie.
How are you?
Good. Good to see you, by the way. It's been a while.
Nice to see you, too, and I appreciated your comments. One question I have on the working with the tribal colleges in Oklahoma, we've been working with our tribal colleges in North Dakota, too, But one of the barriers that we run into, both for them and for us, is the sustainability of operations beyond an initial grant. How did you address that in Oklahoma?
Right. So I'm not sure I understand all of the details because a lot of this was done by the state EPSCoR and director and associate director. But I know at Comanche Nation College, state EPSCoR is paying for at least the first several years of an IT position. What we're doing in the C2 grant, and this is something that we've generally done across the C2 grant, not specific to the tribal colleges, is we only pay lump sums because the C2 grant is only 2 years. So what we can't do is we can't sustain the recurring costs. So, for example, most of the tribal colleges, at the time that we submitted the C2 proposal, most of the tribal colleges were running on 1, 2, or 3 T1 lines. So they had somewhere between 1.5 and 4.5 megabits per second for the entire institution. And there's an awful lot you can't do, and in particular, it's really hard to take advantage of distance learning when an individual H.323 stream, depending on resolution and quality and so on, is going to run between several hundred kilobits per second, maybe up to a megabit per second, although that's usually high def is at the megabit per second range. It's a lot harder, for example, for them to draw down a set of distance learning streams if they know that that's basically going to fill up the entire networking capacity for the whole institution. Now, these are small institutions, right? Typically a few hundred people. But still, to consume that percentage with a single distance learning course is not really sustainable. So part of what we're doing with them is working with OneNet, the state regional optical network, who then works with commercial organizations to find the best deals that we can, which often involves a certain amount of course trading, so that their monthly costs, their recurring costs, don't change. They get some improved equipment on site, and they get improved bandwidth. So by working with OneNet, and particularly now with some of the tribal colleges based on location, the new BTOP grant, so Oklahoma got $74 million out of the BTOP program, is also fitting into this. So we're able to address some of the recurring cost issues through the sorts of horse trading that apparently go on all the time in the networking world. I was very naive. I came from the supercomputing world. You send a request to a vendor, they give you a quote, and then you buy it. It's real simple. In the networking world, it's all politics. It's all about building relationships with the various carriers around your state or whatever the jurisdiction is, and then horse trading capabilities back and forth. You know, at one point, one of the questions was, well, if we give this particular group unlimited use of one room in this building on this campus, then they'll give us this other capability that we actually need. I got to tell you, that's outside of my experience. I think people who deal with networking hear that sort of thing all the time. But so what we've done is by cooperating among these various organizations, we can move capabilities and assets around to open up possibilities for some of these institutions at the sustainability, at the recurring cost level, so that their recurring costs don't go up. We actually did that for the Noble Foundation, the private research organization, where through various horse trading, we're getting them a factor of 20 improvement in their bandwidth at no change in their recurring costs. And that involves paying a lump sum to somebody else, and then they provide the service, and everybody is happy. And part of that was they didn't want to lose that customer, and we were thinking that we would transition that customer to a different organization to get higher bandwidth. So I don't have good concrete answers, but it turns out that a big piece of the answer is knowing what the capabilities are across the state and figuring out how you can make everybody happy and increase capability without increasing costs. And it's really the recurring costs that are what need to be dealt with. Did that answer your question, Bonnie?
Yes. Thank you.
Okay. Good. Other questions? I love questions.
I have a question. This is Bob Peoria at North Dakota State. When did you say that you started to work with the tribal colleges?
We really have only started, and the we here is within the context of cyber infrastructure. Oklahoma EPSCoR has been working with the tribal colleges since they were founded. So the oldest tribal college in Oklahoma was founded in 2002. So this is not something that's been going on for decades. But the cyber infrastructure group, so myself and some of my counterparts at other institutions, really have only been working with the tribals since the C2 grant, so really just over the past 6 months. Now, I've had some interaction with some of them prior to that, but haven't had the ability or opportunity to provide them with any kinds of capabilities until the C2 grant. Are we out of time? Okay. Thank you, everybody.